All right, looks like we're live on this early, early Monday morning. Um, just realized I need an intro video or something. If you make videos, hit me up. I'll see if I can afford it. All right. So this morning, just doing another, chill stream, going through thoughts on DevOps, infrastructure, AWS, code delivery, all that stuff. My friend Rod commented on one previous video that he was curious on, like, what do you do in the early steps or the early, parts of a project, and how do you set it up um, so that these things are easy and maybe avoid missteps somewhere along the way. So did a little bit of searching around. First of all, everybody loves this image of the DevOps graphic, right? You see this everywhere. It's got this like pushing you towards this continuous process. The coding, the building, the testing, releasing, operate, monitor, plan. What they're trying to do here is to get you thinking about feedback cycles and how, like, nothing is ever really static especially in business. Your business is never just maintaining. Either your business is growing or your business isn't. So I think what the DevOps movement is trying to mirror is that kind of mentality you need to do it well. So they're trying to, this descending right hand side of the ops part of this graphic is to get the information from what's happening where the business actually operates back to development and feature lists and all of that stuff. So you'll see this graphic everywhere. I don't really like it. I think it's great for program people, for business people, but I think developers or technologists look at this thing and they know how much complexity there is in that code step or over here in the build and test side. They know there's a ton of complexity in, like, how do you set it up, how do you do all this stuff. So I think there's a tendency on the technology side to look at this graphic and just kind of hand wave it away. So when people come talking about DevOps in their organization, they kind of just roll their eyes or shrug or whatever. And then I found this graphic from Wikimedia and kind of their containerized delivery software delivery pipeline, which is basically the same graphic, just with all of that complexity illustrated, and it gets really deep, really fast. I mean, you're talking about on the way left hand side here. Can you even see my mouse cursor? I don't know if you can. No. So way on the left hand side here, you have unit tests and all of this work going on. In the first left hand side, this is the local environment, your dev environment. Basically trying to make as much happen on the local developer machine as possible, and then that all of this flows up through the various stages. So some dev to build to verify stage, all of these stages of the DevOps process. So I would say this is a very mature expression of that pipeline or that that process. It'd be really hard from the very beginning of a project to have something like this set up and functioning. Especially if you're building custom software without understanding the full scope of the ask. You know, the power of the cloud and of this process is the ability to adapt, the ability to try things quickly, to iterate and find out what's not working, and stop working, you know, stop building things, or stop pushing towards things that are just not going to work. So in the very beginning of a project, you know, I think having something like this as a to aspire to, or for your long-term goals is essential. You want to know, like, what does a healthy pipeline look like, and then, you know, have a roadmap and have some people focused in your project on getting you there. You know, they don't have to be you know, DevOps engineers. You know, some people will take issue with that title, or with that that moniker. We had a kind of vigorous conversation at work the other day about what does a DevOps engineer mean. You know, it's kind of fun. Some people get really passionate about it, but I think having someone thinking about this, and someone just trying to drive your organization towards this, really will drive, because ultimately it's about quality, right? So having somebody working on this will drive you towards a higher quality product. So let's say you are a software, you know, consultancy. So you build custom software for people. If you're an established company, I would hope that you have a team or someone on hand who can build this, or at least, you know, facilitate helping the team on the project build this. I know it's often hard to throw labor at something like this, because you may feel like you're not delivering features, and ultimately we get paid to deliver features in DevOps, you know, or not DevOps, in software consulting, in contract development or whatever. You get paid to build business solutions, right? So it may feel like you're wasting money, or you're wasting time building a lot of these processes out, rather than you know, pushing out the features that people are paying for. But like, over the course of a long project, these things can actually rapidly speed up your development process. So it's all about managing the investment of time early on. I think that's kind of the most critical thing to think about, is, you know, it may seem expensive in the beginning, especially if you have a customer who expects to see, you know, if you have really short deliverable windows, it might be hard to get some of these things set up. And the delivery of, or I should say, the configuration of something like this really varies based on the environment that you're in. You know, if you're doing all kind of greenfield development, nothing exists now, a lot of this stuff can take some serious time to set up. If you're going into an environment you don't understand, it could be even longer. The project that I'm working on at my day job, I've been really surprised with how long it takes things that I would have thought were really simple. Some of them take a really long time. And a lot of that comes down to not understanding the network that we're operating under, or because we don't have full control over our AWS accounts. We don't have full control over our network, and that's for various security reasons and compliance reasons. But it's been surprising sometimes. My coworker has been working on updating the base AMI that underpins all of our VMs, and those are provided to us by an upstream service provider, and they changed the format of the volume layouts. They changed the software that's installed on them. They encrypted them instead of having them unencrypted. So that threw a huge wrench in all of our automation, and it has taken him a lot longer than we expected. He's got a ticket on the board, and it was like, roll the AMIs. Well, it should be a day, maybe two, with our automation that we have set up to just, spin up the new AMI that was delivered to us. We use Packer for that, so have Packer stand up the new AMI, run some Ansible playbooks over the top to configure the software that we need on them, and then stamp out our own custom AMIs based on that image, and then push those out into our various infrastructure. It sounds really simple, and previous months it had been, and then suddenly the machine image that we received was different, so it broke all the automation. So to put like a time estimate on a lot of these things is hard without understanding the environment, but I think just having some time dedicated to this is going to be really important. What I would probably do is, say you have a 12-month contract or a 12-month, development window. I would easily spend 2 months trying to build out a really solid pipeline with all of the automation to build your image or your package or whatever depending on the infrastructure you've selected. This graphic we're looking at here assumes that you're using Docker containers and Kubernetes as the computing platform. At work, we're using serverless, so there's different steps, but the stages are pretty much the same. You still need to package up your application code, install your dependencies, build that package, and then ship it somewhere so that it can be run. So we're not doing Docker images. Well, we are for some things, but the majority of our application is built on serverless, Lambda functions, DynamoDB tables, event streams, stuff like that. So we don't need to worry about Docker image publishing, but the steps are basically the same. We create a zip file with our code, push it to a repository somewhere, and then execute Cloudformation commands that pull that code in and deploy the infrastructure. So I would probably spend the first 2 months of a project building this and getting it going, and making sure exercising every step that gets put in. That could be a long time for maybe in a 12-month project, maybe you don't have 2 months of downtime, or maybe you can't dedicate the first 2 months of it without producing any of the features or anything that customers are expecting to see. So you could start building the front end of your application. So if you have customer facing code or anything like that, you could start, if you break your team up, have one squad working on kind of this process, and another squad working on the front end, the UI. And with the UI, you can often mock out a lot of the back-end stuff just with other, JavaScript functions or whatever. You may not have live code, but you can at least start showing off the flows and stuff through your application and start getting feedback from the customer. Because really, you can see it in this graphic. You have all these lines that arc up and over. Feedback is really what I guess the agile process is trying to do, is trying to capture all of that feedback and get it visible to the team and start to adjust. So you can do those things concurrently. You can build out your beginning UI mockups and get this pipeline rolling, and eventually start deploying those UI mockups with your pipeline, and then you can kind of ease your way into the back end and start building the back end, the interfaces, your APIs, like whatever the core business logic of this app, whatever it does or wherever it lives, you can start building that out. You should also use a concept called infrastructure as code. And I think that's probably something that smaller consultancies or smaller projects will overlook. I think it's actually super critical for the teams to leverage, especially small teams that deploy a lot of infrastructure. It's really, again, this is one of those kind of almost fallacies where you got to hurry up and get things done, so you overlook kind of the simple tasks in the beginning. So if you're doing AWS, the first thing I would do from a DevOps or an infrastructure perspective is I would build a pipeline similar to this that would deploy your Cloudformation stacks. Or if you're doing Terraform, you got to build out a Terraform pipeline. And then once you have that working, you make sure that nobody ever makes changes in the accounts or in the infrastructure manually. Teach everybody how to create pull requests or merge requests if you're using GitLab. Teach everybody how to review them, how to merge them, and all of these deployments and everything that are happening should all be event driven off of merge to master, or whatever your main trunks are. Side note, your branching strategy or repo strategy, those are deep conversations that ultimately come down to preference. There are some good practices, and I don't know if there's a set of like, this is the perfect way to run a project. Some people really like a single repo for a given service or a set of infrastructure or whatever. Some people like to separate it out for your production code and your non-production code. I prefer one repo, and then I prefer to promote that code using tags or whatever. I think that's going to be a separate video because that's a really deep topic. We'll have to do that one in a future video. So the first step I would do is get a pipeline rolling that deploys your infrastructure. If you're a small shop or small company, then I would probably go, and you're using AWS, then I would go with Cloudformation. It's kind of my advice is kind of counter to what a lot of people out there are saying. Almost everybody, Terraform has become basically the software to use for your infrastructure as code. It has it's a little more simple in terms of the syntax, and it's shorter, it's less verbose than Cloudformation. So that is appealing to a lot of people. It also has a really strong module concept, which I actually really like it. But I don't like the way that you have to build a lot of the pipeline and the infrastructure yourself when it comes to running in AWS, unless you go and pay for Terraform Cloud. It may not be in your budget. If you are going to use Terraform, absolutely look at Terraform Cloud as your first option. It handles a lot of the things for you that you otherwise have to solve on your own, and I think that solving that problem is not worth the trade-off of just writing shorter files, or learning. Maybe you're not very good at Cloudformation. Maybe you're okay at Terraform. I would learn Cloudformation in that case, because maintaining a Terraform pipeline is kind of a pain in the butt. And you could spend more time building that than you would just learning how to use some Cloudformation commands and writing JSON or YAML Cloudformation. It's longer, yeah, but I think for stability's sake, it's gonna be the better choice. Now, if you're a really strong Terraform, engineer, and you've built Terraform pipelines in the past, then it's probably not as much of a it's probably not a difficult question for you. Then you use what you're good at, use what you're comfortable with. Err on the side of speed at that point. But for just getting started and not being very familiar, I lean into the tools that exist on the platforms that you're using. AWS has a ton of support and integrations between code pipeline, code build, the actual providers on the cloud. So Cloudformation is a provider in your code pipeline stages. It'll handle, you feed it a template, and it will handle the creation of the stack or the update of the stack. And if that fails, it'll roll it back and it'll visualize it all for you. These are the things that the kind of quality of life things that a custom built pipeline are going to miss. So I wouldn't use Terraform unless you had a lot of experience with it already, because it's the failure states that I think are going to end up costing you more time than it's worth. Just the other day we had somebody, I don't know exactly what they did, but I think they removed some resources from their Terraform file, and through the process of planning and applying, it ended up in a broken state, and one of my team members had to go through and actually manually edit the state file, the remote state file, which was a nightmare. I don't recommend anybody ever do that. It's it's more complicated than writing Cloudformation at that point. So I would just start to understand how these things fail, and that's should help you determine steps to move forward. So first step is get an infrastructure pipeline rolling and get your people using it. Make sure that nobody does anything outside of the pipeline. Numerous times you end up with kind of a complicated or ad hoc environment, because some things are done manually, some things are deployed through code. All of these these steps are kind of disparate and not connected. So you should absolutely be using multiple environments for your development. Ideally, you should have multiple AWS accounts if you're doing AWS. This gives you a nice hard barrier around concerns. You know, keep the environmental aspects completely separate. That is a really powerful way to keep your resources from intermingling and maybe accidentally moving events or data across that environment barrier. To jump the line between accounts, you have to do role assumption and get credentials for that new account. Whereas if you have multiple environments in the same account, you can possibly already have access to those resources just by being inside the same AWS account. So multiple accounts is a best practice. Multiple environments is a necessity in any high quality software product. So going back to like doing things manually, inevitably, if you allow it, somebody will make a change in dev because it's easier. You know, one of those like, well, I just wanted to test it, or I didn't know if it would work, so I just did it real quick, got it working. They committed all the code to their Git repository, and then you try to deploy it to a higher environment and it breaks. And in this case, you could have multiple people involved and not one person remembers every step that happened. So then, then it slows you down because you have to figure out what changed or what's missing. You have to dig into logs. And if you had made those changes to the environment through a pipeline, then you wouldn't be in this state of not knowing which changes are missing. So infrastructure pipelines are critical. You should treat your infrastructure just the same way you treat any software package, any service or anything you're building. It should have some kind of pipeline, maybe not this complicated, but get as close as you can. There's a lot of ways to test your infrastructure code. Like if you're using Cloudformation, you can lint it. You can check that it's valid JSON. Side note for Cloudformation, if you're writing it in YAML, the Cloudformation intrinsic commands are not valid YAML, so you can't actually validate the YAML, which is really frustrating. But there is a command called CFN flip, which will take your YAML and turn it into JSON, your Cloudformation YAML. Then you can validate the JSON and see if that should be pushed through your pipeline. There's linting, there's validation commands, there are change sets. You can leverage change sets to see if you actually want to commit the changes that you put into the pipeline. It's similar to Terraform's plan command. It's a little less easy to use, so it doesn't get used as often as I think it should. When you start to get into the security aspects of your project, you can write rules and stuff to validate your infrastructure templates to make sure that they're not doing things like opening up firewall ports too wide or granting permissions. Overly permissive roles is a huge problem inside AWS, so that's a good thing to watch out for. Something I'm working on right now is trying to understand kind of the policy side of the pipeline. Like if in this graphic here we're looking at like some of these unit tests or integration tests. In there in an infrastructure pipeline you would be looking for patterns and stuff inside your templates. There's a couple tools out there for that. I'm looking into them. I understand them well enough to even make any recommendations yet, but when I do, I'll do a video on that because I think it's a kind of an emerging space that is really interesting. So infrastructure pipelines, super important. And run it inside your automation. So I'm leaning heavily into GitLab right now. We're using it at work. I know a lot of people in my personal life are using it. It seems to be kind of pushing the edge of what you can do in your pipelines, which I think is really cool. Once you have your infrastructure rolling out, then you can start, deploying your application to that infrastructure. I guess it depends on the platform you're targeting for the actual hosting of your app. If you're doing like this image has a Kubernetes cluster in there, you should have a pipeline that deploys your cluster. That's a whole nother topic because Kubernetes can be incredibly complicated if you let it. Your app, I like to do infrastructure code with your application. So if you're building, a serverless app, I like to have a folder in there, or if you're using a framework, they usually have suggestions for where to put those things. But I like to have the definition file, so your Cloudformation or your YAML or whatever infrastructure as code definition you have for that app infrastructure. Keep it in the repo with the actual application code, because that whole repo essentially gets, in the pipelines I build, that whole repo gets bundled up and assembled into a package that you can then use across all of your environments. And that's a concept of like immutable artifacts. So your deployment artifacts are generated from a git commit and then reused across all of your environments. And so I like to store them together because then it keeps all of your concerns in one spot. And then I version it off the git commit, the git SHA, and then use that SHA across all of the environments as a version. Some people like to translate that into tags. I think tags are a great way to express that. Your infrastructure should take in, or your deployment pipeline should take in a tag and translate it into a git SHA, and then behind the scenes use that SHA as your version or the parameters for all of your functions for deployments. So, while you have a team building out the infrastructure pipeline, you've got another team kind of doing your front end mockups. All of this kind of assumes that you have an infrastructure or an architecture already defined before you get into the project. The nice thing about doing infrastructure pipelines and this kind of reusable methodology is it allows you to experiment pretty quickly. You can get away with building prototypes in the UI, just clicking through the console and connecting things together. Personally, I wouldn't ever run anything on there that the customer sees on anything that you built by hand or through the UI, because once you get the infrastructure code written, things may be different. So, if you need to prove it out for your architects or your whoever's deciding things, build it in the console, get it working. But then as soon as you're happy with the direction, then you write the code, get that infrastructure code deployed out there, and then make sure you go back and clean up the resources you deployed manually. you don't want to get down the road, 3 months or so and find out that these databases are still there or these functions are still there. Because you could, if you have an event-driven infrastructure, those things could respond to events. They could create their own events, and you may not know where some of these things are coming from, which is really frustrating, hard to troubleshoot. So, now that we're imagining you've got this kind of these pipelines rolling, the pipelines themselves should be evolving as you run into issues. If you have deployment problems, if you have stability problems, the pipelines should be adapting to your environment, and you should be able to try and smooth out operations as much as possible. All along the way, you should be thinking about observability. Like, how do you know? How does the team at large know when a new version is rolled out or when things are broken? How do you should be visualizing when somebody deployed something to your dev environment and let them know that if it breaks, I like to deploy to dev on every commit, so that forces forces development teams to make sure that their code is always clean and can be deployed from. That's kind of the rule in on my teams. Master branch or whatever your default branch should always be deployable. So anything that's in there should be functional. It should never be broken. If you do break it, you should either roll the commit back or fix it as soon as possible. There's nothing worse than getting into a project and finding out the master branch is broken and can't be deployed. Since these pipelines kind of trigger off that anyway, you could hamper yourself in an emergency if you leave master broken. So don't do that. If you've got a hotfix or a security situation you're trying to respond to, and you need to push that code out as fast as possible, if master's broken, you can't do it. If your tests fail, or if there's broken infrastructure code in there, you can't push that fix up. So have to walk it back or do something to get that working. But as soon as you have the base kind of pipelines working, then I would pivot some of that team over to observability and monitoring, and really start thinking about, like, how do we know the app is healthy? How do we know the pipelines are healthy? And start getting that information in front of the team as soon as possible. I think observability kind of gets, and monitoring, they kind of get punted towards the middle or the end of a project, and they can speed your team up far earlier. If somebody deploys a bad build to dev, having good monitoring and good alerting and good observability can help you troubleshoot that and really resolve that faster than poking through tools and stuff. I think there's a lot of value in that. So I would pivot part of that team, maybe all of it, depending on how small your shop is, over to that, and get a solid pattern around aggregating logs, finding some key metrics to observe and ultimately alert on, and figure out a way to get those alerts in front of people in a kind of smooth people, or ease people into alerting. Don't bury people in too many alerts right away. um, especially in a development cycle. You think about the impact that these things will have on people, but get them in front of people as soon as possible, because then they can start thinking about how, if there's any longer term support in your project or in your contract, then you'll want to start responding to those alerts or those incidents as soon as possible. At least for practice, at least to get it in people's minds that, it's broken. Okay, what do I do? Start exercising those muscles as early as possible. And way before launch, way before the go live date, because launch is almost always bumpy. So having people on hand who have already troubleshot the app, practice with skills, you've essentially trained the team on how to respond to these incidents, so they should be able to respond to them pretty quickly. Ultimately, you should have already had all of these problems in your lower environment or environments if you're doing really solid practice or best practices. If you have more team members, you got part of them working on the monitoring and observability. Hopefully somewhere along there you have some person or people thinking about the security aspects of your application. So do you have to comply with, do you have PCI? Do you have SOC 2? Do you have SOX? Do you have, these various compliance frameworks that you have to target and hit? If you do, a lot of these artifacts, these feedback cycles coming out of this pipeline, we have on the screen here, a lot of those things can also be evidence for your compliance. So have someone thinking about that process, and how do we prove that we are, most compliance frameworks ask you, what are you doing, and then prove to me that you're doing it. It's basically the process. So if you say that, yeah, we use strong passwords, okay, cool, how do you prove that in how do you prove to them that you're using strong passwords? Well, then you would use documentation from the various accounts that you have. So if you have AWS accounts, you would look at the password policy on the account, screenshots from that, or ultimately, infrastructure could define that. Infrastructure code could define those policies. So you can start generating evidence for a lot of your compliance right in your pipelines, and ultimately, that's like the holy grail of kind of the DevOps process, is to build, your security in here. This is where you start to hear people talk about DevSecOps, because we just want to create acronyms out of everything, right? So just jam all the concerns into one word. But getting security into the pipeline, this is where a lot of the infrastructure tests, your linting, your pattern matching, you can make sure that you don't have roles defined with too wide of permissions, or if you have firewall rules, these are the things that almost always come up. It's roles and firewalls are the first kind of the low-hanging fruit, or the easy things that people come up with in their pipelines or in their security documentation. So every infrastructure template that goes out, Rod says, if you don't document your work, it didn't happen. That is so true. Like, I work in federal government space now, and we have a list of controls that's 1,800 lines long. The Excel spreadsheet is massive. We all have really good intentions, and it's hard to document and prove, especially to a third party, when you start talking about government, everybody wants to push paper around, and there's a lot of CYA going on. So, getting your pipeline to generate this documentation so that it's ready to go is a huge win, and it will speed up your project. So, monitoring observability, getting some security in there. I think those would be the next steps. As far as like how these things break down, you generally see people with titles of DevOps engineer, SRE, site reliability engineering, platform engineers. Often the job titles of people who do these things. I personally, I don't really care about titles too much. If you have a good team and everybody's focused on moving forward, then whose job it is shouldn't really matter. But on the other side, the main issue with shared responsibility is that there's nobody holding the bag at the end of the day. It's pretty easy to just kind of do the Spider-Man meme, point fingers at each other. So, these are the job titles, or these are the people ultimately responsible for these things. And, if you have those job titles, you're going to see a huge swath of responsibilities in addition to these things. So, in a lot of companies, you may also be responsible for the operations of the application. It's not my preferred model. I prefer kind of a service delivery model where the team writing the code is also responsible for the app's performance and operations. So, if you deploy a service out into production and it breaks, I think you should be the one who fixes it, because ultimately, whoever has the power and the full context, that's often what a lot of ops teams are missing is understanding what the application should do. They can look at documentation, they can remember updates from meetings or whatever, but at the end of the day, the people who wrote the code ultimately know what should be happening, and that's why I like to empower those people to respond. And if you have a really solid pipeline and process, and you deploy out a broken thing, it should be really easy to roll it back. Shouldn't be a lot of struggle to undo that change. Then you can get into things like feature flags and other release processes, blue-green, multi-version deployments, to really increase the quality and stability. And those would be just kind of natural iterations on the top of this pipeline and your infrastructure. And those people with those titles could be focused on those things, longer term. Your SRE people will probably be, if they're actually following their job title, they should be digging into logs and looking at, invocation times and figuring out why things are, slower than they expected. And again, we follow these feedback lines at the top of the screen here. All of that stuff should go back into your planning and your iteration cycles, and get your development teams, your delivery teams invested in these things. So, an SRE would aggregate data together and say, like, hey, these calls are slow. Maybe we can, speed up these loops, or maybe we can, tune some caching or something like that, and then work with the team to get those kind of those tasks figured out. The nice thing about having a kind of a team like this is your SRE can be an expert in collecting that data and understanding how to tune it, and then your development team doesn't have to be that knowledgeable in it, they can leverage that other experience, but then they should understand the code really well, or the platform, or maybe if they don't understand the platform, then you pull in a platform engineer or somebody with that expertise. And that should be the way across all of it. If you have a person who's really knowledgeable in the pipeline, and your development teams are really struggling with how long it takes to run a series of tests or to get a build pushed out, or any of these things, like these are be feedback cycles back to your platform team, or whoever they are, your DevOps engineers. Most teams that I've worked on, they just haven't had the staffing to really make these things a high quality product. And I think at the end of the day, that's what we're trying to do here, is we're trying to make high quality software. So the feedback is great. Prioritization is always the problem. Yeah, so I think once you have people kind of iterating on pipelines, iterating on your observability and your monitoring, your security policies and practices, then it's just a matter of getting the app finished, taking all the feedback at every stage, at every milestone, and then finishing the project. If you're a development shop, if you build custom software for people, I'm assuming you have developers on staff. Hopefully you have some of these people with titles, the SRE, DevOps, platform engineers. I think this pipeline concept is incredibly powerful, and those people with those titles should be building a product that you can use across all of your projects. They shouldn't be targeting each project, and it shouldn't be a fresh build every time. These things should be iterative and reusable. Just like you wouldn't want to build a custom authentication module for every service or every function you deploy. Eventually you're going to want to standardize and commoditize a lot of those things. Your pipeline should be the same way. So if if you've got developers on the bench who, not working on projects or anything, like, they should be working on this. There should be an internal product that you leverage to speed up your future projects, and then ultimately, your return on those things should be higher, which ultimately should make your company more profitable. The main issue is that these things take a long time to build and really iterate on. So I think that's all I got today. This has been fun. As always, I really enjoy answering people's questions. I like helping people. So if you have any questions, find me on Twitter, find me here on YouTube, come to these live streams. I would love to do Q&A sessions where people have infrastructure questions, or they have DevOps questions. I'm a so-so coder, so my actual coding, advice is probably not the best to follow, but I can help you architect cloud infrastructure. I can help you build pipelines and understand the concepts. That's really where my talents shine. So I think that's it for today. I got to get to work. It's Monday. So thanks for tuning in. Rod, you're the best. Peace out.